Hey, what's up? It's Turpy here, and I thought I'd just walk through the game that me and my friend made. So here in the VS Code window, I'm just gonna go ahead and pull up. So over there on the side, we have the actual game. And right now it's asking me if I want to run the simulation version, and since I'm not in front of it, we're gonna go ahead and sim it. So I'm gonna say true. And we're gonna tell it to do 4 neighbors. So the way this game works, the simulation here, I can go ahead and show you. So the SimTest right here, it checks for a win on the board. So it checks the state of the board to see if all of the buttons are off, because that's the win state. And if the button that you pressed is not the same as the button that you previously pressed, because that's one of our rules, then we go ahead and pass all of the information from the logical state of the board to the game logic. And the game logic, choose game. Yeah, the game logic chooses which one of the games to do. This is just a simple statement for it right now. We're gonna change it to be a more Pythonic dictionary type switch statement to choose between them, because better data structures are better. But right now it works, and as you can see, it's simulating the Foursquare game. It's not anything like actual AI or an algorithm or anything. It's just choosing random buttons, and if the button that it chose was the same as the previously chosen button, it starts it that button into the range of the end of the board to choose another button to try. And it does eventually solve it. It does manage to actually eventually solve it every once in a while. So it's good. It's good. So we wrote the driver here, but the driver functions are up here. So this is the list of every button's neighbors on the board. Since we're only doing a 4x4, it was pretty easy to just do the math on, so we made it a dictionary. I know that's not scalable, but we are not sure exactly how large of boards we intend to do if this is just a game and not a tool to make or mix music live, like with a pad or anything, which you can do with these things. And here it just simply checks for the on-off colors and everything. And this is a bit more scalable because you go for the range the range of the length of the list of neighbors and everything. So that is capable of being scalable, but we just didn't write it the correct way. So to be honest, though, I'm running this on a board that has 32 kilobytes of RAM and 320K of flash and 48 megahertz, right? So is garbage, and I really have to slim down the code and write a lot of stuff from scratch, and also for once care about my file structure. So it's been a good exercise. Here we have the actual button press, and the way that you have to do that in main is that we apply it to what's called the rising edge in this library for CircuitPython and Autofruit, because I'm using an Autofruit Trinket M0. We were using the Feather M0s, but we're trying to make ones that we could sell for like $20. So the Trinket M0s are the way to go, and we've managed to scale down all of our code to run on them. And I've even gotten, progressed to the point where we have the 2 different games. So if I want to show that really quick, I'm just gonna ends the simulation. You'll see right there it stops. We're just going to reload it. We're going to tell true. And the default is 8, so I'm just going to hit enter, and it'll run the 8 neighbor game. I know it's a little bit hard to see. I do apologize for the quality of the camera. I'm doing my best. It's literally a phone camera on an app that is live streaming to a locally hosted website on my home network, and I'm capturing that window. So I tried, I swear. But other than that, I think my next step, other than making a better update pipeline for a few things, like checking if the files that you're updating are actually different time-wise, and if they're actually pushing to the right drive and everything, because the drive letter for this can be different if you have more devices plugged in. So I'm trying to figure out a way to make that pipeline dynamic and write it myself, because, I'm about to go to school for this stuff, so I might as well write it myself. And I don't mean totally from scratch. I'll get help, of course, but I'm not planning on using someone else's stuff. And this has been a really fun exercise. If you are in some microcontrollers and Python or even C, because these can run C, if you're interested in doing things on dot matrices, and also these can have screen attachments, they can have sensor attachments, light sensor attachments, so many things that you can do with these things. So I'd highly recommend it. It's been super fun, and let me know if you guys want to see more when we update it. This is Turpy. Have a good one.